Assalamualaikum and good evening class. So today we will proceed with the new chapter which is about acid and bases. So to continue with this chapter, I hope you can open your module while you watching this video. Okay, so before we proceed with the reactions between acid and base, so at least you need to know what is the acid first. Okay, so acid is basically in the simplest word is contain H plus ion. Okay, if you remember in the previous chapter I told you already, if you want to know that it is acid, you see the symbol. If you look at here, they have H in the front, so this one considered as acid. But in terms of chemistry perspective, acid is actually a compound that will ionize in water to produce hydrogen ion. Okay, so I hope you can write down the definition inside your module. I repeat, acid is a compound that will ionize in water to produce H plus ion. Okay, for your information, H plus ion also can be considered as proton. Okay, so from here you know that acid can be considered as a proton donor. Okay, a proton donor. Why? Because you already write down the definition. It ionize to produce H plus ion. So once they produce H plus ion, they will donate the H plus ion. So we call acid as a proton donor. Okay, so acid, for example HCl, when you put them in water, okay, they will ionize. Ionize means they want to produce the ion. If you see here, HCl, they have the charge of H plus and Cl minus. So here you see that they ionize to become H plus ion. So any compound that ionize to produce hydrogen ion can be considered as acid. Okay, or we can write down the equation as HCl plus H2O. Okay, so as I said here, acid is a proton donor. Proton means H plus ion. If you see here, HCl contain one hydrogen, so they will donate or they will donor the hydrogen ion here. So what happened? They become Cl minus because you already donate your hydrogen. So here you become H3O positive. Why become positive charge? As you know that H is positive, so here you donate hydrogen, so this substance become more positive, so that's why they become positive charge here. And this one we call as hydrosonium ion. Hydrosonium ion. Okay, so acid, so for the definition of acid, you can say it is a proton donor because they donate hydrogen ion, or you can say also it ionizes in water to produce H plus ion or to produce hydrosonium ion. They are the same thing. Okay, so acid basically, for you to know, to understand about acid, it must have H plus ion. Okay, or we can say it's a proton donor because they will produce H plus ion. Okay, so for the acid, as you know that they have a different concentration, or they have different of pH. Okay, from pH 1 until pH 6. So you need to know about your basicity of acid. Okay, so what is the basicity of acid? If you refer to your module, okay, you need to know about the basicity of acid. The basicity of acid is about the number of H plus ion produced by 1 mole of acid. Okay, so basicity means you want to know how much H plus ion that will produced by 1 mole of acid. So if you see for HCl, okay, if HCl is ionized in water, 1 HCl or 1 mole HCl ionized in water, they will produce 1 mole H plus and 1 mole Cl minus. Okay, how I know 1 mole? You need to balance the equation. If you see here, you have 1 hydrogen, 1 hydrogen, 1 chlorine, 1 chloride. So if you see here, the ratio is 1, 1, 1. So 1 hydrochloric acid will ionize to produce 1 mole H plus ion. So the basicity here, basicity for HCl, okay, is 1 because the 1 mole of HCl can produce 1 mole of hydrogen ion, so the basicity known as 1. Okay, so let's look at for the H2SO4. Okay, H2SO4, if you ionize in water, they will produce H plus ion also because they are acid, and also SO4 negative 2 sulfate ion. So you need to put 2 hydrogen here because they have 2 hydrogen. So sulfate already balanced. So if you see here, the ratio is 1 to 1. So what does it mean? 1 mole of acid will ionize to produce 2 mole hydrogen ion. So for sulfuric acid, the basicity is 2. Okay, or the simplest way for you to understand about basicity, you look at the number of acid in the structure itself. So for sulfuric acid, you see here the hydrogen is 2, so means the basicity is 2. HCl, the number here is 1, so the basicity is 1. So let's look at for nitric acid. Okay, if you see here hydrogen is 1, so you know that nitric acid is also, the basicity for nitric acid also 1. Okay, so from the basicity you can know the strong or weak acid. Okay, so before we proceed about the strong and weak acid, you need to know first about the monoprotic acid and the diprotic acid. Okay, so monoprotic means an acid that ionize to produce one H plus ion. Okay, so an acid that ionize to produce one hydrogen ion. Okay, so for example HCl, as you know that just now the basicity is 1, so you call them as a monobasic or monoprotic because they produce 1 mole hydrogen ion only. So same for nitric acid, as we discussed just now, it is contain 1 hydrogen, so we call as monobasic or monoprotic because they can only produce 1 mole hydrogen ion. So for sulfuric acid is not monoprotic or monobasic because they have 2 hydrogen ion here, so we call them as a diprotic acid. So diprotic means acid that ionize to produce 2 H plus ion. Okay, so acid basically you can differentiate them into monoprotic and diprotic acid. Okay, so here if you see here, diprotic will have more H plus ion. So by understanding the concept, what you need to know to understand is acid, they must have H plus ion. The more H plus ion you have, or the higher the concentration of H plus ion, means the acid is stronger. So if you see here, if we compare between monoprotic and diprotic acid, of course diprotic acid will become a stronger acid because they can ionize to produce 2 mole H plus ion, compared to monoprotic acid only 1 mole H plus ion. Okay, so that is about acid. Okay, so now we proceed with your base. Okay, so base is a compound. Bases is are a compound that react with acid to form salt and water. Okay, a compound that can react with acid to form salt and water, or you can say they are proton acceptor. Okay, why means what does it mean proton acceptor? They will receive the H plus ion. Okay, after this when we go to the reactions, you will see the acid donate H plus, the bases will take the H plus from the acid. Okay, so this is the bases, means they can react with acid to produce salt and water. I believe this reaction you already learned in checkpoint year 9. Okay, so you in simple word, you also can say bases are proton acceptor. Okay, so how you want to know they are bases? Okay, all oxides and hydroxides are alkali. are bases. Okay, all oxides, for example sodium oxide, copper oxide, magnesium oxide, lithium oxide, ferrum oxide, iron oxide, all those are bases. Okay, hydroxides, for example sodium hydroxide, lithium hydroxide, calcium hydroxide, what else, potassium hydroxide, all those hydroxides and oxides are bases. Okay, so how you want to differentiate an oxides and hydroxides is very easy. As you see that Na2O is bases, while NaOH is hydroxide. So from here you know this is oxides, this is hydroxide, so both of them are bases. But for your information, not all bases are alkali. Okay, so what does it mean by alkali? Alkali means bases that soluble in water. Okay, bases that are soluble in water, basically they are coming from group 1. For example, sodium oxide. Sodium oxide are bases, and if you put them in water, they can soluble in water, or they can so we call them as alkali. Once they are soluble in water, we call them as sodium hydroxide. Okay, so they will produce so we call them as alkali. Okay, anything base that you put in water that are soluble, you call them as alkali. So basically they are coming from group 1 and group 2. Okay, for example you have sodium oxide, so you also can have sodium hydroxide because they are soluble. Lithium oxide, you may have lithium hydroxide. Potassium oxide, you may have potassium hydroxide. Okay, if you check the properties of the periodic table for group 1, you already learned that the group 1 you can put them in water to produce alkali solution. Okay, so the alkali solution is coming from hydroxide ion. Okay, so some base are not soluble in water. Okay, because not all base are soluble. For example, zinc oxide and lead hydroxide. So these are bases that are remain as bases because they are not soluble in water. Okay, the one that you call alkali if they are soluble in water. Okay, so how to know? For now, what you need to understand, basically the alkali or the bases that are soluble in water is basically coming from group 1 in your periodic table. Okay, okay, so now compared to acid, alkali is a compound that produce OH minus ion. Okay, so alkali, as you said, they are proton acceptor. So basically, for example, you have you have the sodium oxide, Na2O. If you put in water, they become NaOH. Okay, so alkali is basically ionized in water to produce OH minus ion. Okay, ionized in water to produce OH minus ion. Okay, so acid they produce H plus, while alkali or basic basically they are produce OH minus ion, or they will they produce OH minus ion when we put them in water. Okay, so next, if you see your module, so now you know that the acid and alkali will have a reaction. So to have the reactions, you should put indicators. Okay, because you want to know basically when we mix these two, the pH will change. Okay, from let's say you use alkali pH 14, so when you put acid, the pH will drop. Okay, alkali is pH 14 and then acid is pH 1, for example. So if you put acid and alkali, of course the pH for alkali will drop while pH for acid will increase until the pH 7. So basically when we mix the reactions between acid and alkali, you want to reach the pH 7, a neutral point. That's why the reaction is called as neutralization. Okay, So to know that the reactions already reached the pH 7, we should put indicator. So what does it mean by indicator? Okay, so now we will move to indicator. So indicator means a substance change color when a substance that change color when there is a chemical reaction. Okay, so when you put the indicator, when they see the changes in duration, the color of their colors also will change. For example, in neutralizations, okay, later you will see the next video. There is an experiment how we conduct the neutralization reaction. So here you put alkali, so here you put acid. Okay, so if you put acid in alkali, of course the reaction will happen. So you want to know when the pH 7 is achieved, because acid is colorless, alkali also colorless. So you will not see any change without indicator. So at the end you need to put indicator. For example, you put phenolphthalein. Okay, phenolphthalein, the color of phenolphthalein in alkali is a pink color. Okay, so okay, so pH 7, they are alkali, so you put them in alkali, so the color of phenolphthalein will become pink. So of course when you put acid, okay, the alkali from pH 14 will drop the pH because they lost or they gain more hydrogen ion. Okay, when you put more acid means you put more H plus, right? So of course the reaction happen, the color will change. So the color will change from pink, and at the pH 7 they become colorless. So here when you see the color change from pink to colorless, you know that you need to stop the reactions already because it already achieved the pH neutral. So that is we call as indicator. So indicator is substance that can change color when the chemical reaction is happen. So if you see the module, there are several indicator that you can use for the reactions between acid and bases. Okay, first is you can use litmus solution. The color in acid, of course, it is red. Neutral color is purple. Color in alkali, it is blue. Phenolphthalein, color in acid is colorless. For the neutral, it should be colorless also. In alkali, it should be pink. For methyl orange in acid, it should be red. In neutral, it should be orange color. In alkali, it should be yellow. Okay, for the universal indicator, you may refer to your textbook. For different pH value, they has a different range of color. Okay, so you may double check with your textbook. For color in alkali, pH 14, the color is very dark purple or dark blue color. In neutral solution is almost like green or yellow. You may check, you may double confirm with your textbook. And color in acid, the color